Hello viewers, welcome. Now taking you through the story of A-level pure mathematics, and in this video we are going to go through the marking guide for Senior 5 Math Paper 1 end of term 3 for the year 2024. So this video is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So these are the videos we hope to upload in this holiday, but more will be added. Like you see here, there are some schools whose papers have not yet received. So if you're watching this video and you studied from any of these schools, Mengo says, Uganamatas Namgongo, Lubiri, King's College Budo, and SMAC, I encourage you to send me a copy of your papers, either scanned copy or you take pictures and you clear pictures and you send. So I'll do the rest. The typing and the guides will be done by me, so that other students from other schools can also benefit. Remember, in the previous year it was this. Okay, Mengo SS is one of the school which got the highest number of A's in math. So I'm interested in their papers. So if you are a student in Mengo SS, I encourage you to send me your papers on my WhatsApp number 0704989851. Same applies to Uganda Matters Namgongo, Lubiri, KCB, and SMAC. Then if you have not yet bought any resource books, I encourage you to buy these books. They are the ones I highly recommend. For Principal Math, there are 4 books: Math Paper 1, Math Paper 2, Topical Question Bank, and Termly past papers. For subsidiary math, it's only one book which has all notes and past papers with their guides. Physics, there are also 4 books: Physics Part 1, Physics Part 2, Topical Question Bank, and its solutions. So for any of the copies, contact the author on this contact. Or if you want to send the papers I've talked about for those schools I've mentioned, use this contact. So this paper, whose solutions we are going to go through, was done by students in Gayaza High School. So section A has 40 marks and all are compulsory. All the 8 questions are compulsory. So question 1 says, find the angle between the lines this and this. So each time they give you angle between 2 lines, you have to use the formula which is there in the logbook of gradients. So the first thing to do is to obtain the gradient for each line. So for this line, gradient is -2/3. This is done by making y the subject. Then for this line, still gradient is 2/5. So M1, M2, then I can quote the formula. This formula is there in your logbook. And remember, you are encouraged to go with your logbook in an examination room. Except to NAB, because NAB, it is the invigilators which give you their logbooks. So come and substitute for gradients. Gradient M1, gradient M2, gradient M1, gradient M2. The next is so magnitude means what is negative becomes positive. For example, you see here, this is the negative. When you divide, you end up with a result which is negative, but because of the magnitude, we are going to get a positive value. So that basically that's what the magnitude means. Then use a calculator, arctan 16/11 to give you 55.49. So angles are to 2 decimal places. And that's how the 5 marks would come about. So that question was under geometry. Then question 2 says, find the equation of a tangent at point 21 to a curve this. So I think you realize that it is not easy to make one unknown the subject. For example, I can't make x subject, I can't make y the subject. So in other words, I can't separate the variables. Each time you can't separate the variables, it becomes an implicit function. So I have to differentiate implicitly by differentiating on both sides. So I'll come and say y squared, differentiate to get 2y dy dx. Then 3xy, differentiated means that I'll say this is now product rule. So I'll pair this as one variable and this as another. So keep 3x constant, differentiate to y to get dy dx. Then keep y constant, differentiate 3x to get 3. So that's they will have differentiated. But remember the bracket. Some students didn't mind this bracket. This bracket is very vital because at the end of the day when you open, this and this will cause a negative to be here. So if you don't put this bracket, it means that negative will not come. Then this side differentiate 2x squared, you get 4x, differentiate 1, you get 0. So next is collect like terms and make dy dx the subject. But the equation of the tangent, so dy dx, when I substitute for x and y, I'll get what we call gradient of the tangent. So gradient of the tangent is got by substituting for x is 2 and y is 1. So that's why you put here 2, 1, 1, 2. In the end, we will come up with a gradient of negative 11 over 4. Then I will create gradients to get the equation of the tangent. So change in y is y minus 1, change in x is x minus 2 is equal to the gradient. Cross multiply and make y the subject. That will be the equation of the tangent they wanted. And that's how the 5 marks would come about. So this question was under calculus. Then question 3 says, show that the parametric equations, this and this, represent a circle and find the center and radius. So our interest here, when given the parametric equations, we have to get what we call the Cartesian equation. Cartesian equation has only x and y. These are parametric because they have a third parameter. You see this third theta? It is a third parameter. So our work is to eliminate theta. So to eliminate, I'll first make cos theta the subject here to get this. Here make sin theta the subject, you get this. Then I remember an identity in trigonometry from Pythagoras that cos squared theta plus sin squared theta is equal to 1. So substitute here, equate to 1. Then simplifying, here what I've done, I've multiplied throughout by 3, so this and this goes away. Here becomes 3, which is here. Then also divide by 4, so that's how this 4 comes about. Therefore, the locus is in the form this, which is a circle. The center are these ones, AB, so it will be 5, negative 3. Then radius comes from here. Square root of this is radius. And that's what they wanted. So that's how the 5 marks would come about. So that circles was under geometry. Now question 4 is under trigonometry. It says solve this equal to 0 for values of x ranging from negative 180 to positive 180. So you shall come and first rewrite what is given. Then I will expand this using the angle identity to give you, so sine 2x gives you 2 sine x cos x, but because there is another 2 here, so 2 times 2, that's why you get this 4. So it becomes 4 sine x cos x. So now I have similar angles x, because there previously it was x, 2x, x. Now I have x, x, x throughout, which is okay. But the funny thing is that I still have, you see this sine cos, sine cos. What do? I'm going to divide throughout by cos squared x because I want to remain with one ratio, either sine or cos or tan, like that. By dividing by cos, it means that I want to get something called tan. Let us see how. If I say this divide by this, you'll come up with 4 tan squared x. If I say this divide by this, you'll come up with 4 tan x. Why? Because one cos goes with this and sine over cos gives you tan, then this 4 comes here. Then if I say this divide by this, I'll come up with just 35, negative 35. Then 0 divided by cos gives you 0. Now I've got one ratio, so I can solve, and it's a quadratic. So I'll use quadratic formula. Negative b is here, plus or minus b squared minus 4ac over 2a. Then I can get the two values of tan x, then the values of x for each value of tan x. And that's what they wanted. So that's how the 5 marks would come about. Then question 5 is differentiate, so it comes from calculus. Differentiate y equal to o cot x from first principles. First principles, it means that you first increment both sides. So increment this side, I'll come up with y plus small change in y. Here x plus small change in x, x plus small change in x. Then I make small change in y the subject by taking this y this side to give you this, because this is the same as y. Now I'm going to combine into one quotient by getting an LCM. LCM is this. So that divided by this, you come up with sine x times this to give you this part. Then LCM divided by sine x to get sine x plus small change in x times cos x to give you this part. Then from there I realized that is compound angle because the whole of this comes from sine of x minus x plus small change in x. For example, if this is a and this is b, a and this is b, it means that we'll come up with sine a minus b, sine a minus b, like that. So I'll simplify, open this inner bracket, I'll come up with negative small change x. Now what you hear, you should realize that you don't tamper with the denominator. You see the denominator? I'm not tampering with it. Okay, so remember that for small changes, sine small change in x approximates to small change in x. Therefore it becomes this, so this becomes that. I can now bring this on this side to come up with that. So I've got the ratio small change in x over small change in y. Let me first see the marks for this slide before I go to the next slide. Okay. The next is to remember the definition for dy dx. dy dx is equal to the limit as small change in x tends to 0 of small change in y, small change in x. Meaning that where there was small change in x, I'll put there 0. So I'll remain with sine x times sine x to give you sine squared x. Here it is negative 1. So 1 over sine is cosec. Therefore 1 over sine squared will be cosec squared. And that's what they wanted. So now we shall go to question 6, which came from algebra and says solve the equation, this one. So what you realize is that the powers are changing sign. One power is positive, the other is negative, and the base is the same, but they have different quotients. Therefore the first thing to do is to let y be equal to that. Then I substitute. So this, the whole of this will be replaced by y. Then this one will have a negative power. That negative power is the same as 1 over y. So multiply that by y to get that, rearrange to get a quadratic equation, which can be solved using the quadratic formula or by factorization to get the two values of y. But I remember you are the ones who introduced in the y, so bring back the x. Okay, so that means that to make x the subject, I'll power everything by I'll power both sides by 3/2. So this side power by 3/2, you get x alone. Here power 3/2, you get this, which gives you this when you simplify. Same applies to this. 1/16 to power 3/2 gives you 1/64. And those are the two values they wanted. So that's how the 5 marks would come about. Then question 7 says differentiate this, simplifying your answer. So given that the one is to square both sides. When I square both sides, I'll come up with that. Then I differentiate each side. So y squared is 2y dx. Then this side should now be quotient. Quotient means keep this constant, which is here, differentiate the numerator to give you 2. Then keep the numerator constant, differentiate the denominator to give you -2. Then everything divided by square of the denominator. That is what we call quotient formula. Okay, so next to simplify, realize that 2, it can go. So here I remain with y dx. Here I remain with 1 minus 2x. Here there's a negative. This negative and this negative gives you a positive. So remain with 1 plus 2x. So to make the y dx the subject, I'll take this y this side to give you 1/y. But the good thing, I know the value of y is this. So substitute for y to give you that. So it is the reciprocal, you see. Y, for this y, it was, numerator was 1 plus 2x, denominator was 1 minus 2x. So 1/y becomes the reciprocal of this, which is that. So here I realize that this and this are, this and this are the same base. The powers are changing. So you can combine the two. So when this one goes up, it is -2 plus a half to give you -3/2, which is this. Then there's this 2 and this denominator, which is there. Because they're both under square root, you can put the square root outside on all of them. And that's what they wanted. Then question 8 says, when a polynomial fx is divided by x minus 2, the remainder is -2. Okay. When it is divided by x minus 3, the remainder is 3. Find the remainder when fx is divided by x minus 2 times x minus 3. So one is that let the remainder when divided by this quadratic be in the form of this. So when you divide by a quadratic, the remainder should be a linear. That's why you're using that expression mx plus n. So for x minus 2 equal to 0, x is 2, meaning that R2 gives you this. Simplify to get equation 1. Then for the next divisor, x is 3, R3 is that, simplify to give you the equation 2. So there are two equations, two unknowns, so you need to solve simultaneously. Equation 2 minus equation 1 gives you m as 5. Then from equation 2, I can substitute for m and get the value of n as -12. Then I can come and rewrite my remainder. And that's what they wanted. So that's how the 5 marks would come about. So that was section A. Now we shall go to section B. Question 9 says, Roman 1, so this is under calculus. The profit y generated from the sale of X items is given by the function this. Calculate how many items should be sold to receive maximum profit and determine the maximum profit. That is part A. Part B, I think let's first go do part A. Part A, they want maximum profit and the value of X. So for maximum profit, you have to differentiate and equate to 0. So for maximum profit, do y dx is equal to 0, substitute and simplify to get a quadratic. So you either use quadratic formula or factorization. So by factorization, here I use factorization and go to values of X. But X cannot be negative because X is about number of items sold. So you ignore the negative and take the positive. So when X is 4, we shall come and substitute for here, here, and here to get the maximum profit as 208. So that's how the 5 marks for part A would be got. Now we shall go to part B. Part B says the diagram shows a hollow cone with base radius 12 meters and height 24 meters, which is this base radius height. A solid cylinder stands on the base of the cone and the upper edge touches the inside of the cone, which is here. The cylinder is of base radius r meters, height h, and volume v cubic meters, capital V. Show that capital V is equal to this, and hence find the volume of the largest cylinder that can fit inside the cone. So one shall use similarity. Similarity is considering the cylinder ratio and also ratio of height. Okay, let's first go about the diagram and you understand it well. So similarity, you realize that this one from here, here, and here, that's a big triangle. Then also this up to here is a small triangle. So what we are doing, we are first considering height. For this small triangle, height is this, which is 24 minus h, and this is r, giving you 24 minus h over r. Then for the big triangle, height is 24 over this base, which is 12. So this is where this is coming from, 24 minus h over r equal to 24 over 12. Then make h the subject. Why we're making h the subject is because that in the required derivation here, do you see this v? There is nothing like h, so we have to make h the subject so that we eliminate it. So volume of a cylinder is given by pi r squared h. Then come and substitute for h in order to eliminate it, expand, and that is what they wanted. Then for the hence part, they want the maximum volume. So for maximum volume, you have to differentiate and equate to 0. So differentiate this gives you this and equate to 0. Factorize, there are two values of r, but r can't be negative, therefore r can't be 0, therefore r is 8. After getting value of r, I can go back here or here and substitute to get the maximum volume, and that's what they wanted. So now we shall go to question 10. Question 10 part A says, shown is a sketch of the curve this. Find the area enclosed by the curve and its x-axis. So you see the curve, so it has two areas. One is above the x-axis and the other is below the x-axis, meaning one will be positive, the other will be negative. Then part B, sketch the curve this and find the area enclosed by the curve this and the line this. Let's begin with part A. Part A, they have drawn for us the sketch of the curve, but they have not given us the intercepts, so we have to get the intercepts. What is the value of x when y is 0? So factorize, then when y is 0, it means that this is equal to 0, therefore x is equal to 0, x is equal to 1, x is equal to 3. Those are the three intercepts of the curve. Therefore area 1 is from integral from 0 to 1 of this function with respect to x. Integrate and substitute limits to give you this as the area. Then area 2 still do the same integral from 1 to 3, then you substitute limits. Before substitute limits, let's see marks for the slide. Then come and substitute the limits to get the area 2. You realize that area 2 is negative, reason it is below the x-axis. Therefore, when you are adding, you put a magnitude sign. That's when you can get the answer which they want of 37 over 12. Then part B, they want you to sketch the curve of this. First of all, expand, differentiate, then equate to 0 to get turning point. Therefore x is 4. When x is 4, y is that. Therefore the turning point is 416. Then its nature is good by differentiating this the second time to give you this. Because this is negative, like I told you last time, you just draw something like this, where this is 0. So negative means maximum, positive means minimum. So negative is maximum. Okay. So now I've got the turning point and its nature. What about the intercepts? When x is 0, y is 0. When y is 0, x is either 0 or 8. So the intercepts are 0, 0 and 8, 0. Now we can sketch. Show the x's should be labeled. Then you put the necessary points. Necessary points are intercepts and also the turning point. Then I can sketch my curve, and that's what they wanted. Then they also wanted you to, let's see here, they wanted you to find the area enclosed by the curve and the line y equal to 12. Line y equal to 12. So because the maximum is 16, it means that the line y equal to 12 is somewhere here. Therefore, it implies that if this is, okay, this is y2 and this is y1, so y1 is longer than y2, so the area will be here inside, it will be now y1 minus y2, because y2 goes up to here, y1 goes up to here. But we need to get the intercepts, the points, this point and this point. So intersection, the y coordinates are the same. So equate, get a quadratic formula, get a quadratic equation which can be solved to get the two values of x. So now I've got the two values of x. I'm going to integrate y1 minus y2 from 2 to 6. integrate, substitute the limits, and then get the answer they wanted. That was question 10. Question 11 says, part A, a container in the shape of a hollow cone of semi-vertical angle 30. Do you see the word? Semi-vertical angle, half of the whole angle. That's what they mean. Half, semi means half. Half of the whole angle is 30, is held with its vertex pointing downwards. Okay. Water is poured into the cone at the rate of 5 centimeters cubed per second. Find the rate at which the depth of the water in the cone is increasing when its depth is 10 centimeters. I think let's start with part A. 1, we shall need to make a sketch. So this is what they mean by semi-angle 30-30. So it is true that we're going to have the value of h, but you don't hurry to put it there. First leave it as an unknown. So tan 30 is equal to this opposite over adjacent, which is here. Then make out the subject to get this. Tan 30 is root 3 over 3 to give you that. Then remember that volume of a cone is a third pi r squared h. So where there is r, replaced with this to remain with only one unknown. When I have one unknown, I can now differentiate and then substitute. So it is after differentiating that you can substitute for h. Remember that. It is after differentiating that you can substitute for h. So there are two things I want you to remember. One, before you differentiate, the volume should be expressed in terms of one variable. That is one. Two, before you substitute for h, you must first differentiate. Okay, now I can come and get my dh dt using chain rule. Dh dt is equal to dh dv times dv dt. So dh dv is that, which is the reciprocal of this, times dv dt, which is that, to give you that as my dh dt. And that's what they wanted. Then part B says, given that the second derivative is equal to this, first derivative is 0 when x is 1 and y1 is equal to 8. Find y. So they want you to get the particular solution given this differential equation. So one should remember that integration is the reverse of differentiation, meaning that if I have the second derivative and I want to get the first derivative, I'll have to integrate. Hope it is clear. If I have, okay, let me start by this. If I have dy dx and I want to get the 2y dx squared, the 2y dx2, it means that I differentiate. Okay, if I want to go backward, I integrate. So in this case, we have second derivative and want to go backward until we reach y. So we shall keep on integrating. So we have to integrate twice. So if that is the second derivative, integrate to get the first derivative. So I'm going to integrate to get dy dx. So integrate 2, you get 2x. Then integrate this, I'll first get this minus 2. Then here, increase the power by 1. So negative 3 over 2 plus 1 is negative 1 over 2. That is why you're getting this one, x to power with a new power. Then I'll divide by the new power. So 1 divided by negative a half is negative 2. That's why it's negative 2 here. Plus a constant of integration. Then I'll simplify to get that. But I remember what was given, that dy dx is 0 when x is 1. So I'll come and substitute for dy dx and x to get the value of c. After getting the value of c, I can come and replace it here to get the particular solution of the first derivative. But that's not what they want. They want the particular solution of y. So I'm going to integrate the second time. So integrate 2x to get this, integrate this to get that, integrate this to get this, plus a constant of integration. Simplify to get that. But I want to get the constant, so I remember that y1 is equal to 8. Now y1 equal to 8 means that y is equal to 8 when x is equal to 1. Y is equal to 8 when x is equal to 1. So substitute x equal to 1 and y equal to 8 to get the value of k. After getting the value of k, I can now write the particular solution which is required. And that's what they wanted. So question 12a says solve the equation this, and b says solve the inequality this. So first we shall rearrange, take this one this side to give you this, then square both sides, expand, this gives that, and this one, this squared is that, minus twice the product of these two entries, which gives you this, then this squared gives you this. Simplify, and then square again. Expand, then we shall collect like terms to get a quadratic which can be solved to get the two values of x. But we need to test, so when x is equal to 314, left hand side is equal to 43, which is not true because in our question the left hand side was 7, you see, left hand side was 7, so that is not true when you said is equal to 43. What about when x is equal to 6? Left hand side is 6, is 7, implying that x equal to 6 is what they actually wanted. That was part A. Now we shall go to part B. Part B, they want you to solve the inequality this. So the first thing to do is to take everything on one side. That is what you should always never forget. Then for that you combine into one LCM to get one quotient. After combining, the next thing we need to see is you factorizing. So I'll first expand, collect like terms, and then factorize. To factorize, I'll need, it is better if this is positive. That's why I pull out the negative on both sides. Because what you do on one side, okay, I pulled out negative on both sides. And the reason is to cancel it out, because if I don't, it means that I'll have to take it this side to get the sign to change. So I can now factorize and get that. So critical values are got by equating each term to 0. So now I shall come and draw the table of signs. So I shall start from here. Table of signs, we test the signs for different intervals or ranges. That is why these critical values are arranged in ascending order. I think you see, starting from the smallest to the biggest. So we begin by asking, what happens before this smallest value? That is why we put a less than sign here before the smallest value. So before the smallest value, you can get value like -2. So when you put -2 here, you get negative. Put it here, you get negative. Put it here, you get negative. Then the end of it all should be negative. Then after that, we say what happens in between from here to here. So choose a value. It can be 0. So 0 here, negative, positive, negative to end up with a positive. Then from there, we say what happens from here up to here. Positive, positive, negative to give you a negative. Then what happens after the largest value, critical value? We shall get positive, 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 like that. Then from there, to write the general solution, the solution set by looking at this inequality. Less than or equal to 0 means they want negative values. So negative values here and here. So this is our interest and this is our interest. So we shall come and say the solution set is this and this. We are putting O equal to because of the question. If it had no, because the question has O equal to, we also put O equal to in our solution set, but not in the table. And that's what they wanted. So now we shall go to question 13. Part A says find the area of the triangle with vertices A which is 2, 3, B which is 5, 6, and C which is 8, 3. So we shall come and first arrange the vertices in a vertical order. So we shall start with A which is 2, 3, B which is 5, 6, C which is 8, 3. Then you end with what you started with, which is A. Now from there we're going to do some funny multiplication. 1 this times this is 12, this times this is 15, this times this is 24. Then you add these values to get 51. What about this side? This times this, 15, this times this, 48, this times this is 6. Then add to get 69. Then after that you come and say that area is a half of the difference of the sums. Half of the difference of these two sums in magnitude form, because we say magnitude because the order doesn't matter. Even if you say 51 minus 69, you are still correct. Our interest is that magnitude should be there so that at the end of it all, you get a positive area. And that's what they wanted in part A. Then part B says, find the equation of a circle passing through the points this, this, and this. So there you need to use the general equation of a circle. So for point that, where there is x, we put 1, where there is y, we put -2 to get equation 1. Then for point B, where there is x, you put 7, where there is y, you put 6 to get equation 2. For point C, where there is x, you put 9, where there is y, you put 2 to get equation 3. Then I can solve those equations simultaneously. So equation 1 minus 2 gives you that. First, I want to eliminate C. So simplify to get equation 4. Then equation 2 minus 3, you get that. Simplify to get equation 5. So now equation 4 and 5 have only 2 unknowns, so I can solve them simultaneously to get the values of G and F. So what I'll do, I'll come and replace this F for G, replace G here. So substituting gives the value of F out as that. Then from equation 5, G is that. Then from equation 2, I can use either equation 2 or 1 or 3 to get the value of C. Then I can write the whole equation as it is, which is this x squared plus y squared minus 2gx plus 2fy plus c. Simplify to get the required equation of a circle. That was question 13. Now question 14a says prove that this is equal to this. So left hand side, one is to multiply both sides, both numerator and denominator, by 2 to come up with that. Then I can use reverse of factor formula. For this I'll come up with this, for this I'll come up with this, for this I'll come up with this, and for this I'll come up with this. Then from there I will collect like terms where this and this cancels to remain with sine 7 theta minus sine 3 theta. Then here cos theta cancels, remain with cos 7 theta plus cos 3 theta. So that has been reverse of factor formula, and now we are going to do factor formula itself. So sine plus sine is 2 cos sine, 2 cos sum divided by 2, so 7 plus 3 7 theta plus 3 theta divided by 2 gives you 5 theta. Then 7 theta minus 3 theta divided by 2 gives you 2 theta, like that. Then cos plus cos is 2 cos cos, which is that. After that, you realize that this can cancel and this can cancel, remain with this alone, which is here. And sine over cos is tan, and that's what they wanted. So that was part A. Now we shall go to part B. Part B says, given that A, B, C are angles of a triangle, prove that this is equal to this. Okay. So I'm going to use factor formula on these two to give you this. Then here I'll use double angle formula identity to give you that. Then from there I'm going to rearrange. You see, this with this gives you positive 1. Then this one becomes negative, which is here. That's why you see negative here. Then we shall now have this, which is here. Okay, but we know that a plus b plus c is equal to 180, meaning that a plus b is equal to 180 minus c. Therefore, cos a plus b is the same as cos 180 minus c. But 180 minus c, when you expand it, you get negative cos c. Why am I doing that? I want to replace this one with cos c, with c. So I'll come here and say this, replace it with negative cos c to give you this. That's why you see a minus here, yet here there was a plus because of this negative. After that, we shall factorize out. You see, first of all, this one we don't tamper with it anymore, because in the required proof, let's first go back and see something. In the required proof, there's already a 1, so we're not going to tamper with it anywhere. Our interest is now the remaining parts. So I'll leave this one, then I'll come here, deal with these ones. I'll factorize out negative 2 cos c, negative 2 cos c. Here I remain with cos c, here it is plus cos a minus b. Now after that, I'm going to do something fun again. Do you know what I'm going to do? I'll replace back the a plus b inside here, not here, but here. So if cos a plus b is equal to negative cos c, it means that cos c is equal to negative cos a plus b. So I'll replace this with negative cos a plus b. The reason why I'm doing that is because I want to do factor formula. Now here what has happened? I've pulled a negative out. When I pull it out, With this, it becomes positive. But this one becomes negative because I've put out a negative. So I can now combine cos minus cos is negative 2 sine, which gives that. Now this negative with this, okay, negative 2 with positive 2 gives you negative 4. So I'll come up with the required proof. And that's what they wanted. Then question 15. Express in two partial fractions this, and hence find the value of dy dx when x is 2. So questions of this form are usually funny because sometimes, okay, when you see questions of this form, the first thing to test is whether the fraction is improper or proper. So in this case, we are lucky that our fraction is proper. Do you know why? Because in the numerator, highest degree is 3. In the denominator, highest degree is 4. So it is already proper. So you can proceed. If it is not proper, you have to first do long division. So I'll come and split it or decompose it into partial fractions with unknowns. Then I equate the numerators, not the equivalent sign. It is very important. So putting x equal to 1, it means that the whole of this is 0, and the whole of this is 0, so remain with this and this. Giving you that, and b will be equal to 2. Then putting x equal to 0, it means that the whole of this will go. Here I remain with only 6. Here I remain with this on the right hand side. So simplify. This is negative a, this is b, which is, and b was already known as 2. Then this is d, which is here. So there are two unknowns still, so you shall get an equation. Let's see the marks for this slide before I go to the next slide. Then putting x equal to negative 1, we shall come up with that. Simplify. Then you'll get the value of c as 0. Then putting x equal to 2, substitute. Simplify, substitute for b, for c, and also replace a in terms of d. So substitute for d in terms of a to remain with only a as the only unknown. Therefore, a is negative 1. Then from equation 1, d will be equal to that. So you have got all the unknowns, meaning you can now write our partial fraction. Therefore, y is that which is equivalent to this. But it's also told us to differentiate. So differentiation, it is easier if you first take all the terms up. That's why you see negative powers. Then I can differentiate. Bring down the power. This with this gives you positive 1. Reduce the power by 1. Differentiate the inner bracket, which is positive 1. Then you bring down the power, it is negative 4, reduce the power by 1, differentiate the inner bracket. Bring down the power, negative 3, reduce the power by 1, differentiate the inner bracket. Then simplify. And that's what they wanted. So when x is equal to 2, substitute. Okay. So that was question 15. Now shall go to question 16. 16 says, part A, Julius operates an account with a certain bank which pays a compound interest rate of 12% per annum. He opened the account at the beginning of the year with shillings 500,000. and deposited the same amount of money at the beginning of every year. Deposits, okay, at the beginning of every year. Calculate how much he will receive at the end of 6 years. I think let's begin with that. So this is the rate, principal, n, number of years. So amount at the end of the nth year for each depositing is given by this. This is the compound interest formula. Then substitute for P for R to give you that. But because it deposits every year, we shall get the total amount, which is A1, A2, up to A6. Then substitute because each amount has this, we pull it out. Then we only write this. This power 1, power 2, up to power 6. So that is a GP with first term as 112, 1.12, and common ratio as 1.12. Therefore, substitute for A and R and N to get the total amount they wanted. So that was part A. What about part B? Part B says, prove by induction that this is equal to this. Okay. So one, you have to first generate the series, which is that. Then you start for n equal to 1. Left hand side, you take the first term, which is this, and gives a half. Right hand side, you substitute for n to give you a half, so it is true for n equal to 1. So it is only true because right hand side is equal to left hand side. Let me repeat. It is only true because the value of the right hand side is equal to the value of the left hand side. We're going to see how vital that is. What about n equal to 2? Left hand side, you take the first two terms. Right hand side, you substitute for n. So still true because left hand side is equal to right hand side. So you only say true on when the right hand side is equal to the left hand side. So now we shall suppose that it is true for n equal to k. When it is true, it means that left hand side is equal to right hand side. So here we are saying the word suppose because we cannot show it, we just suppose. But when it comes to n equal to k plus 1, we can show. So let's go to n equal to k plus 1. That is our major interest. So it is advisable that we begin with the right hand side, where you just substitute for n. Then left hand side, you add all the k plus 1 terms, which are these ones, But the whole of this is among the assumption that's equal to this. Okay, then you realize that already in our right hand side we have 2 here and 2 here, so you don't tamper with that 2. We also have a minus, so our interests are these 2 terms. So let's just put them in a bracket and then deal with them. So get LCM for this, and so that you can put them under one quotient. Then open these brackets for the numerator. You can put this, simplify this with this gives you k, and this with this gives you 3. You realize that this is the same as this, so it is true for n equal to k plus 1 because the left hand side is equal to right hand side. After that, you can now conclude. You can now write a conclusion that since it is true for n equal to 1, n equal to 2, n equal to k, and n equal to k plus 1, then it is true for all positive integers of n. And that's what they wanted. So that brings us to the end of this video. Thank you for watching, and be reminded this video will be on my part 2 in the term limit for 2024. So if you have not yet subscribed, please click on the subscribe button